All right, so now that we know the basics about alkynes, let's think about how we're going to synthesize them. So just a little bit of review, right? Remember we had alkyl halides. When we added a base to them, we could form alkenes through an elimination mechanism. And so we can do something very similar here, except now since we want to make a triple bond, we need to add two alkyl halides, right? So if we have two alkyl halides and we add a base, we can then make an alkyne. And also think about how you're going to get here. If you start off with some kind of alkyl halide, you can go to the alkene, and then from the alkene, you can add Br2 to it to get two of your alkyl halides here, and then add a base to form your alkyne. The two alkyl halides do not have to be on separate carbons. They can be on the same carbon as well. So this works as well. Again, you'll form an alkyne. All of these go through an E2 mechanism. So for example, we have some kind of base. It'll pick up this hydrogen to make our alkene through this E2 mechanism. And then we'll simply repeat this yet again. To form our alkyne. However, for this step right here, you can see it's a little bit different. Now we've got a double bond already formed, so we have a triple bond now. In order to do this final step, we need a strong base. And it somewhat depends on the substrate, but for most time, you're going to use a very strong base to make these alkynes. And the most commonly used base is going to be your sodium amide. So the sodium is just a counter ion. It doesn't really do anything. The real base here, the real magic is with this NH2 minus, right? So NH2 minus. And this is usually done in liquid ammonia. And so ammonia is normally a gas at room temperature, so you do these at very cold, usually around like negative 30 degrees Celsius. But anyways, it's just a very strong base. So again, if you have two of these alkyl halides, you can add your sodium amide to form an alkyne. If you have two terminal alkyl halides, right, two on the end here, and you add some base, you'll form an alkyne as well. And so this one right here, where we've got carbons on either side, this is known as an internal alkyne. And then when we have this triple bond on the end of our molecule, this is called a terminal alkyne. And terminal alkynes are a little bit special because we have this hydrogen here. And if you think back to when we learned about acids and bases, this is actually pretty acidic. And so if we add some kind of strong base, such as our sodium amide, we'll actually deprotonate this and form the anion. And so what you'll see here is when we make these things, we have a second step of adding water, and that's just to reprotonate our terminal alkyne. So for example, if you see these terminal bromines, the first step, you're going to deprotonate them and make your alkyne. And then in the second step, you'll reprotonate your alkyne to get your end product.